And today we are so fortunate to be joined by Dr. Alexander Koo. Alex completed his PhD at the Institute for History and Philosophy of Science and Technology at the University of Toronto in 2015, where he focused on indispensability arguments for mathematical realism. Alex has since expanded his area of research into broader issues regarding the application of mathematics in science, scientific inference, and scientific realism. Alex has also focused on developing new pedagogical strategies for some of the larger courses at the Department of Philosophy. He has revamped several courses into hybrid, flipped, and online, and is always looking to innovate and improve on the classroom experience. When not completing the nature of numbers, when not contemplating the nature of numbers, Alex can often be found playing ultimate frisbee, playing board games, fixing up his bike, and eating his way through the city. I want to really welcome Dr. Alexander Koo, who will be joining us to speak about why we should trust science, a philosophical inquiry into reasonable beliefs. Welcome, Dr. Koo.
Hi, everyone. Thanks, Lydia. Thanks for being here and having me. So I just need a second while I switch over to the lecture slides. So yeah, bear with me, please. Great. Hi. Okay, my name's Alex, and yeah, thanks for coming today. And my talk is called Why Trust Science? A Philosophical Inquiry into Reasonable Beliefs. We'll see how much we get through into me sort of launching some compelling argument. But yeah, let's sort of dive in. So the question we're facing is, oops. There we go. The question we're facing is sort of a standard one. You know, we know that there's a lot of sort of general discussion about how much we should put public trust or individual trust into science as an enterprise and the results of science. And we also know that this question actually has sort of important ramifications and important implications for our lives and also sort of the world that we live around. So the most sort of talked about traditionally question about trust in science is this sort of classic story about whether or not vaccines cause autism. Of course, another sort of hot topic is whether or not we should believe in global warming and climate change being a man-made thing. And clearly these beliefs matter in terms of how they shape policy and sort of governmental level decisions. Now, of course, this sort of talk was originally planned a while back, but has recently become sort of probably more important, I guess, because there's sort of this like huge new sort of discussion in terms of why we ought to trust science or should we trust science in terms of all this sort of scientific things that are going on with respect to COVID and whether or not, you know, the science is out or we should wait or how we should dictate policy and so on. So this is sort of an important sort of topic in today's world, or at least I hope you sort of feel that way. And yeah, I'm sort of just going to scratch at the surface for some sort of philosophical inquiry into sort of the nature of how science works and whether or not we should sort of believe in the results. Now, what I'm doing is introducing sort of a branch of epistemology. And epistemology is a fancy word that philosophers like to use. And epistemology really is just about the study of knowledge. So when we do epistemic sort of research or we explore epistemic issues, what we're asking is, you know, what should we claim is knowledge? What should we claim is belief? How do we know things? What should we trust? And so on. So the epistemic question that we're addressing here today is sort of this relationship between belief and knowledge. Now, clearly, these are different things. You know, there are certain things that I know and certain things I believe, right? So like, I know that I am sitting in my basement right now and I believe, what do I believe? I don't know. I believe that the Leafs will win the Stanley Cup in my lifetime. I don't know if that's true, but I believe it. So we've always wondered, or philosophers have always wondered, what the difference is between knowledge and belief. Now, there's this very classic tripartite definition of knowledge, just means three parts. And it goes back to Plato and Socrates and perhaps even earlier. But the basic idea is that for something to be knowledge, if you know something, you clearly have to believe it, it has to be true, and you have to be justified in believing it. Now, I'm not going to go into too much detail on like what these individual things mean. I just want us to sort of have an intuitive understanding that knowledge requires justification and knowledge requires truth. So when we shift this back to the central question, which is why should we believe in science? Well, it seems that there's a natural answer. The natural answer for why why we ought to believe in science is because science is true. And we hear this all the time, that science generates knowledge, generates facts. And of course, from Neil deGrasse Tyson, this very famous quotation, the good thing about science is it's true, whether you believe it or not. So we seem compelled to believe in science because people are telling us that science is just true. It's just pure knowledge, a sort of bastion of facts, essentially. But is this actually the case? So even though I'm trying to make the case ultimately that we ought to believe in science, I'm sort of going to take a detour and sort of argue against some of the common reasons that people sort of say when they try to convince you to believe in science and follow their results. So is it the case that science is true? Well, actually, if you look at the history of science, we have a bit of a problem. The history of science is filled with all these theories that we sort of would look back and laugh at right now. So unless you know a lot about the history of science, you probably don't recognize the bulk of these. But over here, I have some sort of humoral theory of medicine. This is an old theory of heat called the caloric theory, where heat was thought to be some strange fluid. This is the theory of phlogiston, Newton's theory, any theory that used ether, which we used up until the 20th century. This is a Lamarckian sort of evolutionary theory. I guess evolution is not the right word, but it's a Lamarckian theory of how sort of animals change. And of course, on the bottom left are just a variety of different theories that we sort of thought that the atom looked like and how much they've changed in such a short period of time. So if you look at the history of science, what we realize is that a lot of theories, which we called science at the time, we ended up falsifying. We ended up sort of proving or showing that these theories must be wrong. So there's a very famous argument against the general truth of science, which is that you pick any sort of old scientific theory and you would say, hey, look at this old scientific theory. This scientific theory was believed to be true. People in their time thought it was true, but then ultimately it was falsified. It was proven wrong. And you grab another scientific theory and you realize, hey, the same thing. In fact, if you look at every single scientific theory up to our current set of scientific theories, people in their time believed that they were true, and ultimately they were falsified. They were proven to be false. And so this is just a look at the history of science. Now, immediately you can see that a conclusion follows, a philosophical conclusion, which is, therefore, our current scientific theories that we already right now believe are true will probably be falsified. Now, this is a clever argument. It's made famous by a philosopher named Larry Loudon. And it's interesting, but it's also sort of obvious. Doesn't it seem weird that we are saying our scientific theories right now must be true? Isn't it surely the case that in 1,000 years, scientists will look back at our science and be like, well, they thought all these things, but they were wrong. They just didn't know more things which we have uncovered in the past 1,000 years. Not only is that likely, but we actually sort of hope that's true, right? We hope that there's scientific progress beyond what we just have right now. Now, this pessimistic meta-induction, in fact, scientists actually already know this. If you look at some of our leading scientific theories, we have quantum mechanics and sort of particle theory, and then we also have general relativity. These things don't really play very nicely together. So scientists already know that there are some problems and that our total scientific set of facts cannot be all true. And in fact, just the other week, there was all this sort of hype about how some new testing on sort of the muon was going to generate some new physics for us, because it sort of shows that our current physics isn't right. So this isn't sort of like a surprise. So when we go back to the claim of why we ought to believe in science, we have this famous quotation from Neil deGrasse Tyson, very compelling, but it turns out that it's actually not true. Science, as it stands right now as a totality, isn't true. Well, that might be troubling for our sort of target question. So instead, we might shift towards analyzing how science is justified. What makes science a justified practice? Why ought we to believe in it? Maybe it's in the way it works. And as sort of most of you have learned about the scientific method in school, The answer typically is science has this really nice method. It's this really beautiful method for generating sort of new hypotheses and conclusions and for testing them. And of course, the other two elements of science isn't just the scientific method, but we have, so this picture in the top right, this idea of reproduction. Reproduction really matters because if you do some sort of scientific experiment to get a result, then other people have to be able to reproduce it around the world. And then, of course, the last step we have in the sort of method of science is this notion of peer review, right? So a scientist will get some result and they'll try and publish it. But before they publish it, it's looked at very closely by other scientists, other experts in the field, before we deem it to be a scientific fact. So we have this nice method which justifies the results of science. But again, is this really the case? Does the scientific method actually get applied? Is there sort of good reproduction and peer review? Well, philosophers have looked at the practice of science for a long time, and they really just concluded the practice of science is really messy. And there's no real singular method that really captures everything. And you can also sort of just see this in the sort of differences in terms of main scientific theories that we know. So on the one hand, we have the theory of evolution. But if you think about the theory of evolution, which is a pillar of science, it doesn't make any predictions. There are no hypotheses that we can do and test and apply the scientific method to. The theory of evolution really doesn't generate much. On the other hand, you might say we have particle physics. So this is a picture of the LHC, this huge particle collider. And you'd be like, oh, well, particle physics generated these interesting predictions. And so we smashed some things together. And then people discovered things like the Higgs boson. But the problem with that is that's not really reproducible. It's not like we can build a secondary particle collider the size of a small city to sort of test these results. And this idea that we have issues in replication sort of has infected psychology, in fact. And this is known as the replication crisis, which is to say that we have all these scientific results that we can't reproduce. And even when we try, most of them fail. So what about peer review? What about protecting ourselves from making mistakes in knowledge claims by having other people sort of vet it before we publish them in scientific journals? Well, it turns out that hasn't gone so well for us either. So this chart here is a chart that depicts the number of retractions that papers make in terms of scientific research. And you can see it's just grown astronomically. And some of the most sort of cited papers in terms of the public, cited scientific papers, are actually papers that ended up being retracted because they were deemed to be faulty, but they weren't caught at the time of publication. And this has really hurt the reputation of science in general. So when we think again about the justification of science, maybe thinking about the methodology doesn't really take us so far. But instead, I can point to some other sort of believed fact about science, which is that even if it has some messy methodology, even if it makes some mistakes along the way, at the bare minimum, science is objective. You know, science is this nice objective area of knowledge, whereas other fields, especially in the humanities like, you know, English or art, these are not objective things, they're subjective. So this is, again, commonly believed, but is it true? So to know the difference between subjective and objective is really just to think that most people say that if something is subjective, it's like your personal opinion, right? And if something is objective, it doesn't depend on you, or it doesn't depend on sort of anyone else's position or perspective. It's just like that's what the universe sort of thinks or would see. And so we typically think that the difference between subjective and objective is a difference between what is considered a fact versus something that's a mere opinion. And this matters to science because science is in the business of cranking out objective facts. And so we often think that science is free from any social factors, free from any factors of sort of the individual in terms of their bias or anything like that. But again, is this really true? Is science super objective? So it's been well documented that there are all sorts of subjective factors in the generation of science. So perhaps the most famous, which you may or may not heard of, is something called publish or perish, which is basically the idea that individual scientists, they have careers and they need to sort of get jobs and secure funding. And the best way to do that is to have some fancy reputation by publishing all these papers. So a lot of the time, scientists will publish things that aren't so great just so that they have a line on their resume so that they can get the next job or get the next grant. Now, related to this is the reality that lots of people fudge their data. So here, this is a depiction of something called p-hacking. And p-hacking is this sort of sophisticated way of rigging the math so that you can make your data look particularly fancy so that it seems that there's a conclusion, there's sort of some statistical link between your data and the hypothesis so that you can publish. And p-hacking happens all the time. Of course, there's also the lure of becoming a big celebrity like Dr. Oz. So you end up saying outlandish things because that's how you get on Oprah and TV. And other social factors are sort of perhaps less obvious, but more sort of dominant, I guess, in the generation of science. So there's a massive gender gap in science, and this can really hurt. So here's an example. Is science really objective? Well, here's a quotation from Science. I certainly think that women, though generally superior to men in moral qualities, are inferior intellectually. Well, who said this? None other than Charles Darwin. Now, you might think that's a cheap shot towards science. Darwin was so long ago, so you're probably right. Here's something more recent. In this study, they were trying to figure out why a man's brain has greater mass than a woman's, which is a fact, I guess, of statistical averages. So here's the quotation from the paper. We found that the average IQ of men was about 4 points above that of women. So if men had an average score of 100, women would score 96. So the idea here is that the argument here is that men are just inherently biologically more intelligent than women. There's so many ridiculous things about this quotation, and this is from Dimitri van der Linden, and this is published in 2017, published in an actual journal. And it's just like laughable. Like there's so much ridiculousness about this quotation, like the fact that we would even use an IQ test, which is like already well known to be a bad indicator of intelligence as intelligence. And my favorite part of the quotation is that van der Linden has to sort of explain what 4 points above means in this 196 example, but like whatever. There's so much ridiculousness about this, but these are still published in scientific journals and constitute scientific knowledge. So is this objective? Like clearly not. Here are two more facts about the realities of science and how it might impact us. So in the year 2000, the American government found that 8 out of 10 prescription drugs taken off the market pose greater health risks to women than men. And it has also been estimated that women are 1.5 times more likely to develop an adverse reaction to a drug than men. And the question is why? Well, it's because, there's actually 2 reasons, but they're linked. One is that in randomized control trials, which is how we test drugs for the most part and to see if they're safe and if they're effective, overwhelmingly, the people who are in random control trials are men and not women, but it's still deemed to be objective and apply and work for everyone. And a second related thing is that lab mice, all those little sort of like white lab mice that you see, they are all male lab mice. They're not female lab mice because science has decided that female lab mice, it's too complicated to test drugs on because of the presence of hormones like estrogen. And so that's why we don't test on female lab mice, which is ridiculous because clearly male lab mice also have hormones as well, but somehow science has deemed those to be acceptable and objective, which causes these types of problems. So is science purely objective? Well, no. There are clearly social factors in science and clearly problematic ones, in fact. So why should we believe in science? If I've just argued that science isn't true and science isn't justified in the way that sort of most people believe, am I really saying that you can believe anything you want? You can go and believe alternative facts? It's like, no. Let me just be crystal clear. I am not saying that at all. I am saying we ought to believe in science, but we need to be careful as to why. So in philosophy, we talk about the strength of a claim. So here's a claim like it's raining outside. And if you think about this, there's lots of sort of ways we can sort of grade the strength of the claim from impossible to certain. Now, if a claim turns out to be certain, as in it's 100% the case, we can say that we can know that claim. There's knowledge because it's true. But in reality, very few things have that level of certainty. Like, for example, I think that I'm a human being, but am I certain? Well, I don't know. I've never like cut myself open to see if I actually have like a biological heart. Like, for all I know, I'm some like machine or like some Pinocchio or something brought to life. Like, I just don't really know. Is it possible? I guess. Is it probable? Not really. So, in reality, what we have is this continuum of belief. And when we consider claims that are just in the realm of possibility, which are almost all claims, we have to decide whether or not our belief is unjustified or it's justified. So, an example of an unjustified belief is something that's very unlikely. For example, a belief in astrology or pseudoscience like homeopathy. These things are unlikely, and so I don't really believe in them, or I ought not to. Now, what about things that are just merely possible? Well, science is full of things that are just merely possible, these sort of like ideas or posits or whatever, like string theory or many worlds interpretation of our existence and all these things. So, should I believe them? Well, it's a bit unclear, depends on how probable I think it is, but if I believe it, I'm not super justified. Now, the question is, what are justified beliefs? Well, those are the things that are really highly probable. And so, what I'm going to suggest is, of course, science, or at least our science that is not super speculative, that has achieved this like massive consensus, this 97% consensus. That's a reference to climate change. We can talk about that in the Q&A. Is these highly probable things we are perfectly justified in believing, and that's why. Now, the mistake here is that most people argue that we ought to believe in science because it's certain, right? Because of knowledge. But that's not really the case, as what I've sort of been trying to explain here today. So, why is science justified? I've just said that it is. Well, it turns out it's a really complicated story, and I'm doing a bit of a bait and switch here because I can't actually get into it in too much detail. There's lots of philosophers, historians, and so on that have written about why science is justified. Now, interestingly, they vary radically in their beliefs, but this falls under the sort of broad spectrum of philosophy of science. And overwhelmingly, though, regardless of what they believe, how good science is in terms of truth and stuff, they all believe we should believe in it. So, why? Well, because there's a difference between claiming something is totally true and approximately true. And science is definitely not totally true, but it's got some good stuff in it. And there's a difference between saying science is objective versus science aims at objectivity. And science certainly aims at being objective. And of course, there's a difference between saying science has already been proven to be right and true, which it hasn't, and saying that science has a massive amount of evidence already for why we ought to believe it. And this last claim, this claim of evidence, is empiricism. And empiricism is this idea that we ought to believe in experience and evidence, and that's why we believe in science. Now, this is a subtle distinction, but it comes with payoffs. So there are three payoffs to really understanding why we ought to believe in science, or three payoffs that we can suggest now. The first is that once we really realize that science is a bit subtle in this way, we as individuals are better at recognizing bad arguments against science. So if someone says, oh, there's a scientist out there who doesn't believe in climate change, we know better how to navigate that argument and why that's a bad argument. It's because we know that science has social factors in it, and individual scientists will do things for the sake of their careers. And that doesn't bother us because science isn't just purely objective, it aims at objectivity. We can also see when institutions are not doing a good job of portraying science, and we can then demand that our institutions do better, like the media, politicians, etc. And we can demand that they actually act according to scientific evidence. And this comes from a better, subtler understanding of how science works. And finally, once we realize that science is messy, it does make mistakes, it's not perfect, it's not just true, we can demand and strive and hope to make science better. We can try to make it more objective. We can try and make it more diverse. We can try and make it closer to the truth. And this requires us not putting it up on this pedestal of just raw belief. Okay, so what was the point of this talk then? Well, because on the one hand, I'm sort of saying, don't listen to Neil deGrasse Tyson about why we ought to believe in science because it's true. But then on the other hand, I am saying, oh, but believe in science. So what's the difference? Well, I hope to have teased out the difference in that sort of 3 payoff slide, but I'll sort of just sum it up really quickly here on my last slide. And the idea is that there's a difference in why we ought to believe in things. And this difference really matters to philosophers. Philosophers want to know reasons for belief, not what you believe. And in this sense, philosophy is like the opposite of regular everyday life. In everyday life, I don't have time. I just want to know what you believe. I want to know, are you this? Are you that? So I can decide if I want to be friends with you or never talk to you again. We want to create our echo chambers, and that's fine. We all have busy lives. But in philosophy, I actually don't care what you believe. What I care is why. Because having the right reasons can expose you, or the wrong reasons, I should say, can expose you to sort of bad arguments and make you sort of just believe things for the wrong reasons. But having the good reasons is everything for a philosopher. So what I've hoped to sort of illustrate in this talk today is that, yes, we ought to believe in science, but we ought to believe it for the right reasons and not just to have blind faith and trust in the idea that science is true and science is perfect, because it's not. It's messy. But in knowing that and embracing that, we get a better understanding of science, and we can all work towards applying that understanding to get a better world that we can live in. Okay, that's my talk. Thanks a lot.
Thank you so much, Dr. Koo, for such a timely talk.